All right, yeah. The first question, most of you miss it, 90%. 90% of you miss the first question. Answer is false, not true. It looks correct, but you need to really look at the whole picture. It gives you impression correct, but if you really want to, so here, I want to explain this way. Yeah, first, let me read the statement. To evaluate a polynomial, the higher the degree, the more multiplication we need. Okay, all right. When we say, so this is a statement. When we say a statement is correct, we need 100% correct, right? Do you agree? 100% correct. If there is 1% of chance incorrect, we cannot say it's correct, right? Do you agree? Yeah. So here we only need to find a small special cases that this statement is incorrect. Then we disprove it. Right? That's the main point. Yeah. So here we know how to find let's say counterexample. It's very easy to find a counterexample. Okay? All right. See here, let me give you a counterexample. Very easy. Okay. For n equals 1024. Okay. To evaluate polynomial, yeah, we can use a monomial. It's okay, right? Yeah. If some people really want to use polynomial, x plus 1024. Okay. All right. Yeah. No problem. Okay. All right. When we do this by repeated squaring, repeated squaring, ten multiplications, right? Based on repeated squaring, we need 10 multiplications. Lowercase?
I'm just wondering about your use of the notation. Like, is that lowercase n equals 1024 or uppercase n equals 1024?
Lowercase? Why it's important? Lowercase?
Familiarize myself better with the notation that is used in such analysis.
Right. Notation. It's not that important. Yeah. Notation. If we just convey our idea, yeah, it's okay. Yeah, notation not that important. Okay. All right. Yeah. So 10. All right. This number pretty small, but if we use let's say which number? So let me use a number 31. How about that? 31. Okay. All right. Let's in this second part of this kind of example. 31 much smaller than 1024, right? Oh. Yeah. Yeah. I need to use some cloth. Yeah. Otherwise, writing is not easy. Yeah. Much smaller, right? Yeah. So why I do 31? Because 31 equals 32 minus 1, right? 32 minus 1. It's a power of 2 minus 1. Maybe 31 is relatively small. So let me do this. 31. How about 63? 63. power of 2 minus 1. Yeah. Why I do this? Yeah, because 63, we use the, repeated squaring, binomial exponentiation, right? Yeah. I didn't mention this terminology. Yeah. In our reference, some students read a book. So the method is called a binomial exponentiation. Yeah. Anyway, we know it. To do this, 63, we need to calculate x squared, x fourth, x eighth, x 16th, x 32nd, 5, right? 5. We need 5 multiplication for preparation. Multiplication for preparation. But after that, we need to write x64 equals x times square fourth, eighth, 16th, 32nd, all right, yeah, together 63. All right. How many more? 1, 2, 3, 4, 5. Yeah. 5 plus 5, also 10. Yeah. But this is much smaller, right? Yeah. If you want to really get it more than that 10, we can consider n equals 127. How about that? Power of 2 minus 1. Yeah. 127, you will get 6 plus 6, right? Yeah. Preparation step, you need a 6 multiplication. Then you multiply all of them together, another 6 multiplication. So this way you get 12 multiplications. Greater than 10, right? 1,000 something, we need a 10. But here, 63, we need a 12. Which one is more, right? The higher degree, 1,024, that high, we need a fewer multiplication. Is that a contradiction to our current statement? Counter example. Not 100% correct, right? Yeah, that's why it's false. Yeah. That's the first part of the explanation, but there is a second part. Why? So many students got the impression, yeah, although you have the impression because in our problem solving many times we use some principle. Our principle is the larger the problem size, the harder the problem, right? When we solve a problem, we want to reduce the problem size to make the problem easier, right? So that principle we use frequently in our problem solving. Okay? Yeah. So we want to reduce our problem size based on a principle: the smaller the problem size, the easier the problem. And here, what do we do? It's not wrong. Yeah. It is quite effective. It's not wrong. Yeah. But what do? We based on a principle. Yeah. All right. So here, these two words, they have different meaning. The statement, principle. When we say some statement is a principle, we mean most of the time it's correct, right? For a principle, we do not mean 100% correct, right? Yeah. If some proposition or some statement is 90-something percent correct, then we can use it to guide our problem solving, right? We can use it as a principle to guide our problem solving. Yeah? Because if it is 90% correct, it is a pretty good principle, right? Yeah, it is very good principle. Yeah, we have a good chance to be successful, right? Yeah. So we use it as a principle. But when we use it as a principle, we know there are exceptions. Yeah. Yeah. Because it's not 100% correct. Okay? So we allow exceptions. Okay? Yeah. For exceptions, then we do some special treatment, right? Yeah. Yeah. If we encounter exceptions, then we will, do something different, special treatment to, get around those exceptions. So that's the way we apply some principle. Yeah. But here, the statement, every time when you see some statement, okay, by default it's a statement. Yeah. Then we will use the statement understanding, not principle understanding. So here we will use the statement understanding. If it is correct, it must be 100% correct, not 90-something% correct. Okay? So for that reason, it is incorrect. It is false. Okay? Yeah. Yeah. Try to understand. So in different situations, yeah, so you need to consider, do we use this statement as a principle or not principle? Okay? As a proposition. Right? Yeah. A proposition must be, proposition. Yeah. So we can prove it's correct or not. Okay?
A value for the predicate for which the value is false.
Yeah. Right. Depends on the specific n values. Yeah. N numbers. Yeah. So you cannot say, always. Yeah. You can say most of the time. That is correct. If you say, most of the time, yeah, it's correct. No problem. Yeah. Yeah. All right. Yeah. So this is the biggest problem. Yeah. For others, for number 2, so many students pick C. We know for growth function, we need to drop the leading coefficient. 1/2 should be dropped for growth function. Yeah. So many students pick. Yeah. So, all right. Yeah. So this, I think it should be okay. Yeah. Number 4, most of you got it. Got it. Yeah. But I want you to know how to get it, right? How to get? Oh, question. What? Oh, correct answer number to D. D. Yeah. 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 Number 3. Yeah. If I do not say anything, because it's on my solution file. Okay. Yeah. So that's why. Yeah. So I skip. But if you want me to explain, I can explain. Yeah. Yeah. If you want me to give further explain, yeah, I just say a little more. Yeah. Yeah. This one, I hope, when you choose, yeah, the correct answer is true, but I hope you know how to get it, right? Yeah. Not by guessing. Yeah. Guessing is true. Yeah. So how to get it? Yeah. 3 elements in place. So first, you fix those 3 elements. Okay? Yeah. Let's assume the first 3 elements, we make it in place. Okay? All right. Then all the remaining elements, yeah, we have quite some remaining elements. We want to make them out of places. Yeah, out of places. Yeah, out of places. You can. Yeah. So, how to make it happen? You can make them in place first. After they have the in place positions, then you do rotation. Okay. Yeah. You do rotation. Okay. All right. So each element moves to its next position, but the last one, you shift to the first position. You do that rotation, okay? Yeah. one position, yeah, any direction, yeah, shift. Yeah. Shift to left, shift to right. Yeah. All elements are out of places. Yeah. Very easy. Yeah. 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 Sometimes, yeah. If you do, because the reason I say you need to know how to get it. Yeah. Because if you do not know the reason, when I give you different questions, you may get a wrong answer. Okay? Sometimes impossible, sometimes it's possible. But you do not know how to get it. So there, if you feel very hard to get it, you may say it's impossible. But actually, it could be possible. Yeah. All right, yeah, so that's number 5, another big problem, this question. This question, the correct answer is B. Yeah, but so many students pick A. Okay, so many students pick A. Yeah, all right. The reason is they couldn't. Yeah, they couldn't. So here we need to calculate it. Yeah, because here this n is a specific number. So, because if we do not know, we know the limit, right? We know the limit, but here it's not a limit case. Here it's not a limit case, right? Yeah. Limit we know, B. In the long run, B is larger. But here we only do it on one number. One number, we don't know which one is, which one is larger. Okay, so we need to calculate a little bit. All right, yeah, let me quickly calculate it. Yeah, all right. For A, yeah, because 100 we need to write 10 square, right? 10 square, then 10 to the 10th. Okay, all right. So then, by the algebraic product, 2 times 10 to the 10th, right? Yeah. By the algebraic property, multiplication. 2 exponent numbers we multiply together, 2 times 10 to the 10th, right? Then we take log base 10. Yeah. Log base 10, the base is gone, right? Yeah, because your exponential function base, log base the same, so the base part is gone, so we only have the exponent part. So this equals 2 times 10 to the 10. Okay? First number. Second number, let's see if we can get a second number larger than this one. Yeah. All right. Second number, 100, yeah, we write 10 to the 2 times 10 to the 10th. Then multiply another exponent number. We know exponent number, several levels, we do multiplication, right? Yeah, we do multiplication. So the second case, so here, let me just skip one step. We do multiplications. Yeah. All right. 10. Yeah. So the second, multiply -6, right? -6. Yeah. 0.6 positions after decimal point. So 10 to the -6. Yeah, there are 6 positions after the decimal point. Okay. 5, 0, and 1. So 6 positions. Okay, yeah. So 10 to the -6. Yeah. All right. Then this number equals 10 to the 2 times 10 minus 6. 10 to the 4th. 10 to the 4th. 10 to the 4th. 10,000, right? 10 to the 4th equals 10,000. Okay? Yeah. All right. 10 to the 20,000. How about that? 10 to the 20,000. So the second number equals 10 to the 20,000th, right? Compare the exponent number 20,000. Here, exponent number 2 times 10 to the 10th. Much smaller, right? Yeah. So here, if you do in this way, you know, the second number is much larger. Yeah. But many students, I saw on their papers, they calculate the second one, yeah, but couldn't get the right one. Yeah. Yeah. So this another big error problem. Okay. Yeah. All right. Yeah. Because in my solution paper, I didn't explain this, so that's why I spent some time explaining here. On my solution paper, I only check B correct. Yeah. I do not explain why B is correct. Yeah. Maybe I should put there. Yeah. I will revise. Yeah. Let me revise. Yeah. Write some formulas. Yeah. All right. Yeah. Other questions looks fine. Yeah. Yeah. And number 8, actually many errors. The correct answer is 8. Yeah. In my solution, I explained. Okay. Split. You know. Yeah. So here I want to save some time, but here I just want to say, many students they select B or D. Yeah. I give partial credit. Okay, I give 2 points partial credit. Yeah. All right. Oh, yeah. Oh, sorry. I need to move up. Okay. Yeah. All right. Yeah. Number 9. No. Yeah. Number 9. Most of you got it correctly. Yeah. Because when you calculate, when you use formula times 13, use this formula to do the calculation, you get 18, right? Yeah. 30, 40, 20, yeah, you get 18. Greater than 17. Yeah. Just by this formula. Yeah. All right. Number 10, A, yeah, but several students give me E or, yeah. So here, in this situation, you should draw a simple diagram. Okay, all right. Simple diagram. X1 greater than X3, then greater than X5. You also know X3 greater than X4. See? X4. After you draw a diagram, you know X1 is above 3 elements, at least 3 elements, although we do not know where is X2, right? X2, we don't know which position, up, down, but it doesn't matter. We know X1 is greater than at least 3 elements. It cannot be the median, right? Median must be third smallest, third largest. You're already greater than at least 3. So it cannot be third smallest. X1 cannot be the third smallest. Yeah. Based on this observation, third smallest. You can say X1 cannot be the median. Yeah. For the other elements, there is a chance for any of the other elements to be the median. Yeah. Only X1 has no chance. Yeah. Okay. All right. Yeah. So then other, yeah. So the easier simple question, I just move a little faster. Yeah. Number 14 looks fine. The answer is 6. Yeah. But so many students give me answer 5. The answer is 6. So many students give me 5 to get a 6. Yeah, but I look at their formula, getting 5, not quite right. Yeah, yeah. The 6, you take the right view, 5 elements. We need 3 of the 5, not maximum, not minimum. But we know how to find the maximum minimum. If we eliminate maximum minimum, remaining 3 are the solution, right? Form a solution. Yeah. So we need to find, so here, find max and min. We have the formula 3 times 5 minus 2. 3 times 5, 15. Round it up, 16. 16 over 2, 8. 8 minus 2, 6, right? Yeah. With 6 comparisons, we can find both maximum minimum. After you find them, take away. Take away maximum minimum from the group. Remaining 3 left. That's what we need. Yeah. So the 3 together form a solution. Yeah. So here, I like you to use this, we call it complementary view. Yeah. Yeah. Complementary view. Yeah. Yeah. So we do not try to select 3 explicitly. The first one, second one, third. If you do that way, you need more comparisons. No. We just work on its complementary set. The elements not in the required group. In its complementary part. Negation. Yeah. Or we do the negation part, okay? Negation part. Not belong to the required group. Yeah. Then easier. It's easier. Yeah. All right. So, yeah. Number 15. Most of the students did well. Yeah, really well. Yeah, based on the hint. Yeah. This time, because I try my best to force you watching the hint video. Yeah. So based on the hint video, yeah, most of you can get the correct answer easily. Yeah. As I remember, 1 or 2 students missed this one. Yeah, 1 or 2 students. But I look at the students claim the bonus points. As I remember, 4 students didn't claim. 4 students didn't claim. Yeah. Yeah. All right. This one, yeah, this one based on the hint video, so it's another big problem. Yeah. Yeah. This one also, yeah. Oh, this one, although based on the hint video, but several students didn't consider factoring this condition. Actually, not in place. Yeah, because those students give me apply the formula correct, times 14, get a 105. Then done. Yeah, several, 4 or 5 students at least. Yeah, but this case, if you look at it, because the array is in descending order, XA is in the middle, right? The middle one, descending order, it is in place. In place. Yeah, not satisfy the requirement. Yeah. So you need to move it out of place. Okay. Move it out of place, right? So you can either do swap 2 adjacent elements. Do not jump. If you jump, then you reduce too many inversions. Yeah. Only switch between two adjacent, you can also do the switch between these two. These two ways, one of the two. You can move it out of place, but you only reduce the inversion by 1. So reduce by 1. So you get the 104 answer. Small number of students miss this step. Okay, all right. Why it's so hard to move this file? All right, Number 18, number 19. Based on my grading, pretty challenging. Pretty challenging. Only these two, only a very small number of students got both correct. Some students got one of the two. The answer, both 10. 10 multiplications. Minimum possible. So many students got 12. Some students even more than 12. So 10, we need to split. So you really need to try a little bit. Try different ways. So in my solution, I gave 2 or 3 possible way to split. So there are several ways. So here, to save time, I do not need to do it explicitly because on my solution, I do it explicitly. So you can see how do I split. Not very complicated. Oh, those students, the reason those students, all those students give me answer 12 for this one, they use the repeated squaring or binary exponentiation. We represent it in the binary. We do the binary representation. Okay, that based on 0, 1. Then we do the multiplication. If you use that way, you get 12 multiplications. 12 multiplications. Okay, But because we can use repeated cubing, right? We do not have to do that kind of split. We have a lot of different ways we can split. So the best we can do, we can reduce from 12 to 2 multiplications. So for 12 answer, I give partial credit, 2 points. 2 points partial credit. Okay, All right, 19, number 19, I give 3 different ways. 3 different ways. Sometimes I saw some students gave a different solution other than my solutions. Then I will include the student's solution. So I may have 2 or 3. Maybe 2. 2 or 3. Could be 2. Anyway. All right. Number 20, based on the hint. So you did quite well. We followed the hint. So we calculate the first, without considered condition, we have a formula. After that, because this condition can save us 5 comparisons, then we minus 5. All right. So this is the basic part. Part B, basic part. Then part C, 5 challenging questions. Part C, the first big problem for part C. So let me say it again here. For part B questions, you see answer. So I ask you for answer. That means if your answer is correct, I give you full credit. But if you want to get a partial credit, you need to give me a little more details. In case your answer is wrong, but because you give me some details, if your detail is relevant, then I can give you partial credit. That's the rule. In our first class, remember in our first class, when I explain the syllabus, I talk about part B, part C. Yeah. All right. Then part C, the rules are different. Yeah. Because part C, they are challenging questions. Challenging questions, then I do not ask for short answer. Yeah. I ask for full solution. Full solution. Oh, I cannot move up. Oh, yeah, here, move up. Yeah, why so hard? Move it up. Oh, yeah. Part C, you see, I use this word solution. I expect a full solution. Yeah. Answer is not enough. Answer is not enough. Details, more important. Yeah. Okay? Yeah. But when I did grading, so many students still only give me one number, one answer. So many. Okay? Yeah. In my first video explaining the syllabus, I gave that rule. Yeah. Probably I need to remind you. Yeah. Yeah. So one student asked me, because you already forget. But when you see solution, you give me one answer number. When you see the word solution, do you feel you should do more work? You put your more work on it. Yeah. Because the rule here, if you only give one number answer, even if it is correct, you can only get 1 out of 4 points. So here, even correct answer, you can only get 1 out of 4 points. Yeah. The 3 points for the details, solution details. Details is important. Okay? Details is important. So many students skip that part. Because if you put detail, you can at least earn partial credit. Even your answer is incorrect, you can earn partial credit. Okay, all right. Yeah, so that's the first big problem. Common big problem. In our midterm, we apply the same rule. Okay, midterm, same rule. So last five for you, for your in-person class, last 5, you work at home, right? Yeah, you work at home. You work at home, you have more time. Yeah. Don't forget to put details of your solutions for all 5 questions. Okay? Yeah. I give you the solution word. Yeah. I hope so you do not confused with the basic part. Short answer requirement. Here, full solution requirement. Yeah. Midterm. Yeah. Because you can earn some partial credits. You put details. Put the relevant details. Yeah, not garbage details. Okay? Relevant details, you can earn some partial credit. Yeah. Midterm. I hope nobody missed this part. Okay? Yeah, because so many students lost many points. So many points. Yeah. All right. That's the first problem. The second problem, still on this question, yeah, I saw, because here the inequality, you have each inequality containing 3 elements. But some students still treat it as 2-element way. 3 elements, that's different. You should do things differently. Yeah. Yeah. Some students still, yeah, I noticed some students did it like our previous one. Yeah. What is previous one? Yeah. Remember? Yeah. 19. Not 19. 20, right? Yeah, 20. Yeah, this one. Each inequality only contains 2 elements. 2 elements, right? Yeah. So you use that way. But 3 elements, the middle one, the middle elements can never be maximum minimum, right? So all the middle elements can be eliminated immediately. Before we do anything, we can eliminate all the middle elements in the inequalities. Yeah. All eliminated. Okay? Yeah. Then, after elimination, your size number can be reduced, right? Yeah. 1, 2, 3, 4, 5. Yeah. Minus 5. 16. Yeah. After elimination, yeah, because those 5 elements all out of consideration. Okay? Yeah. Yeah. So you do not include those 5 elements. So you reduce the problem size. Then you can use the previous question, yeah, number 20, that one, similar way. Yeah. But you need to do one elimination step. Yeah. Okay? So that's the main problem. Yeah, that's the main problem. Yeah. All right. Yeah. Number 22 and 23. Let me see how much time. Okay. Yeah, I should have enough time. Yeah, why? Yeah. Why so hard? I never have this kind of problem. I need to do something special. Yeah. Oh, yeah, maybe, yeah, I use my mouse pad a little better. Yeah, all right. Yeah, yeah, so I gave the hint. So then, based on the hint, several students still missed a little bit. Yeah. So based on the hint, calculate U, calculate V, calculate W by Horner's rule. W, you need 3 multiplications. V, you need 1 multiplications. U, you need 2 multiplications. Yeah. So then, for this step, you need 6 multiplications. All right. Then after that, the second step, yeah, some students missed slightly the second step. Yeah. Second step, U to the 4th, V square, W to the 8th. Yeah. We do square sharing, yeah, based on the hint, also hint. Yeah. All right. First, 1 square sharing for all these variables, V, W to the 4th square. So 1 square share. First level square sharing. Then you have, U and a W with a square structure. So V single out, yeah, because V you cannot do further square sharing. Yeah. But between U and the W, you can do another round square sharing. Yeah. Yeah. Some students got this step correct. Yeah, that's good. But then do the multiplication counting. You need to do carefully. So let's count how many. Yeah. This is first, right? Yeah, first. Okay. Then this one, second. Second. All right. Then this square, third. Okay. All right. Then another square, fourth. Then this square, fifth. Five more multiplications. Yeah. Counting, so something counted 6. A little, yeah. All right, yeah. So like this, okay, yeah. So that's this one, yeah. And the second one, the biggest problem. Yeah. Still based on the hint. Based on the hint, you can write in the, using the Pascal triangle, you can write this way. Okay, yeah. Many students got this step. But when you calculate a of x plus b of x, then many students didn't use the best way. Yeah. Why? Because some students calculate a and b separately. If you do these two terms separately, you will use more multiplications. You need to combine them. Combine the terms before you apply the wholeness rule. Okay? So combine the terms, combine the like terms before you apply the wholeness rule. Yeah. Because when you calculate separately, by wholeness rule, you need 2 multiplications. Then by wholeness rule, you need 3 multiplications. Then 2 plus 3, 5. But remember, these 3 terms and the first 3 terms of b of x, they can be combined, right? Yeah. When you combine them, you get a0 plus b0, a1 plus b1 x, a2 plus b2 x squared, b3 x cubed. Yeah. When you combine like this, then you apply wholeness rule. Because wholeness rule, you treat the parentheses, all these parentheses part, you treat as one number. Okay? And in this way, actually, you share multiplications. Yeah. For the first 3 terms, you share multiplications. Yeah. If you do not combine the first 3 terms, you need to do twice. In A part, you do once. B part, you do second time. That's not efficient. After combination, you only do once. So you save 1/2 of the work on the first 3 terms. Okay? All right? Yeah. Combination. Yeah. All right. Yeah. So that's the main missing part. Yeah. All right. Number 24. The answer is 2. Okay, 2 multiplications. 2 comparisons, not multiplication. Sorry. 2 comparisons. In my hint, I give you the direction. You should target this 2. Yeah, many students still give me 3. Yeah. Remember, we did a similar question before, right? Yeah. I remember we have an earlier question. Yeah. I intentionally give you that early question to at least to inspire you. Oh, not this one. Yeah. I remember 7-element problem. It's a 7-element problem. Yeah, this one, number 16. 7-element problem. In my hint, I ask you can reduce to 3. Yeah. Work on 3. Okay. Oh, let me also explain. Yeah, so those students follow this hint, 3, but when they do the 3, they give me the best case, not the worst case. Yeah, so this is another big problem I forgot to mention. So for this question, so many students give me answer 2 comparison. 2 comparison, that's for the best case. Okay? Yeah. So the best case, you need 2 comparisons. Yeah. Because you compare, first one, second one happen to be the best situation. Yeah. So you need 2. But we need a worst case. Because the best case, you didn't cover all the cases. There is another case you didn't cover. That case is worse. Worse, you should pick that worst case. Worst. 3 comparisons. Okay. And in this question, I didn't mention best case, worst case. If we do not say anything, it must be worst case. The default case is the worst case. Yeah. Why? Yeah, I explained. I remember in some situation I mentioned the logic. The logic is only when you cover the worst case, you solve the whole problem, right? If you just cover the best case, you didn't solve the whole problem. You leave some uncovered cases. But if you cover the worst case, we can solve for the worst case, then we can solve for any other better cases, right? Because other cases can only be better than the worst case. We can only do better for other cases, better than this worst case. So that's why we only need to cover the worst case. Good enough. We can say we cover all the possible cases. We can only do better, not worse. Not worse than the worst case. That's the logic. Yeah. So many students only give me the best case solution. Okay? Yeah. So in the midterm, don't make the similar mistake. Yeah. Always work on the worst case. Any step. Yeah. When you have multiple cases, target the worst one. All right? Yeah. Target the worst one. Yeah. So you have several multiple cases. Yeah. 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 All right. So that's another important mistake. Yeah. All right. All right. I pretty much cover most, so I leave the hardest one left. Yeah. Yeah. Oh yeah. Yeah. 24. 2 cover. Yeah. Yeah. In my hint. Yeah. Based on the previous question, question number 16, question number 16, because if we compare question 16 and question 24 here, the only difference is this condition. X5 is not the maximum. The only difference. Yeah. X5, not maximum. Okay? Yeah. If we remove this condition, then these 2 questions are the same. Okay? Yeah. Remove this condition. Yeah. 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 Because sometimes we can remove first, right? Yeah. Then we add it back. Yeah. That means if we remove this condition, our solution is 3 comparisons for the worst case. 3 comparisons. Then, now we add this condition back. So, we only, after we add 1 extra condition, we have more information, right? The more information we have, the better we can do, right? Well, because if you have more relevant information, then you can do better. Okay? Yeah, that's the, natural understanding. Yeah. Yeah. So, better than 3 comparison, then we target 2 comparison. 2 comparison better than 3 comparisons. Yeah. But 1 comparison, that's, too much. Too much to do. You ask for too much. Okay? Yeah. So the reasonable target is 2 comparison. Okay? All right. So we work. Yeah. But when we work, how can you do it? That's how to use this condition wisely. How to use it wisely. Wisely. That's important. Yeah. Because if you use it in the wrong way, then you cannot get the best. Yeah. Wisely here means in your first comparison, don't touch this. Don't touch this condition in your first comparison. Okay? Because in your first comparison, X5 is involved, you waste the precious information. Okay? That's not the best way to use your precious condition. This condition, very important. You should delay. Delay to touch it. Delay, because why you delay? You do comparison on other unknown elements. After that, you collect information, right? When you have more information, you use your precious condition. That is better, right? When you have more information, you use a precious condition. Then you can, get the most of your given condition. Get the most. But if you have nothing, then you use it, then you cannot get the most out of it. That's the understanding. You cannot get most out of it. All right. So our first condition, compare x1 and x2. Okay? Yeah. And we can assume x1 less than x2 without loss of generality, right? Okay. All right. Here I draw a diagram. x2, x1. Okay? All right. Our first comparison. Then we are ready to use the given condition, because in this situation, we have more information. We can get the most out of it. Yeah. All right? Yeah. But now we have the max, we know, x5 is here, below that max. Okay? All right. Yeah. All right. All right. Then, all right. Our next comparison, compare x1 and x5 as our second comparison. Okay? Second comparison, x1. All right. Second comparison, you only have 2 possibilities, right? Yeah. Yeah. Greater than, less than. You only have 2 possibilities. Okay. Less than or greater than, 2 possibilities. All right. Let's look at each of the possibilities. Yeah. If x1 less than x5, yeah, x1 less than x5, can we get max here, x5 here, x1 here? So this is for the less than case. Less than case is this x5 solution, right? Not maximum, not a minimum solution, right? That's the first case. Second case, yeah, x1 greater than x5. In this case, we use the other part, x1, x5. This is the greater than case. This case is x1 the solution. right? In the middle, yeah, not the maximum, not the minimum, yeah. So we solve it. We solve it. Okay, yeah. All right. All right. Yeah, I have 3.5 minutes. Yeah, let's say 4 minutes. I need to complete the last question. But last question, I only give you the main idea. Yeah. All right. First, we have the information. Yeah. 4 pairs. Yeah. X2, X1, X4, X3, X6, X5, X8, X7. All right. Winners group, losers group. Okay? Yeah. Yeah. Let's say W group and L group. Okay? All right. Then largest, second largest, smallest. Yeah. First, let's look at find the largest and the second largest in the winners group. Okay? Yeah. So I call it W1 largest, W2 second largest in the winners group. Yeah. But because that's the local largest, second largest, right? Not the global. Global containing all the elements. Local largest. But W1, even it's the local maximum, because it is in the winners group. So it is max, right? It is max. Yeah. But the second largest local second largest, it may not be the global second largest, right? Yeah. The second largest may not be the global second largest. So you still need to consider for other elements, which one has the possibility greater than W2. Yeah. Yeah. W2, let's say W2 here, W1 here. Okay? Yeah. Yeah. X2, X4 cannot be greater than X2. X1, X3 cannot. Yeah, because they're less than. They are corresponding, upper part. X5 cannot. So the only one that could be greater than W2, that's the X7. So you need one extra comparison between W2 and X7. Yeah. One extra. Okay? One more here. Yeah. All right. But you need find the second largest. Second largest. Okay? All right. So the second largest, yeah, here you do another pairing. X4, X2, X8, X6. Okay? Yeah. Here you need two comparisons. Okay? Assume that. Then after that, one comparison you get W1, right? One comparison, you get W1. Yeah. Then how to get a second comparison? Yeah. I will finish. Second comparison, W2, the larger one between X4. This you get W2, right? This you get W2. Okay? Yeah. All right. So 1, 2, 3, 4. So get W1, W2, you need 4 multiplication. There's 4 comparisons. Okay? All right. Then this is extra, right? X7, X6. So 4 plus 1. You need 5 comparison. You get the largest, second largest. Then for the lower half, same 5 comparison, right? 5 more. Lower half, because symmetric. Upper half, lower half, symmetric. So 5 more. 5 more plus 5 more, you're 10. 10 is the answer. Okay? Yeah. So that's the solution. Yeah. All right, that's it. Yeah. So use use the solution file, today's review, to prepare for the midterm on Thursday. Okay? But Thursday, you only need to do the part B, 10 basic questions. So when you do preparation, if your time is very tight, you can focus on the basic part first. Because the challenging part, you still have a little more time, right? So after Thursday, you still have a few days for the challenging part. So you can focus on the basic part. Okay? All right. Question from the Zoom side?